Hello, I am Tom Rusk and I'm here to demonstrate a solution using RFID and Arduino technology. Designing my request for proposal, I created a problem where the managers of Tenco Incorporated needed a portable attendance system for use around their facilities. They tasked me with creating a prototype that meets certain criteria for their needs. The design solution needs to be easily transportable, lightweight, and powered simply by a laptop running Windows 10. They would also like the attendance system to be quick and easy to use for employees, and also easy for managers to configure without much programming knowledge. To decide in this prototype, I decided to study and create an RFID solution and found this could be implemented using a small, efficient Arduino microcontroller platform. So why did I choose this technology for my solution? Well, first off, RFID stands for radio frequency identification and can be used for many applications that require identification mechanisms. In this project, I used the RFID-RC522 module along with the Arduino Uno. The RFID uses electromagnetic fields to transfer data over short distance. In order to read an RFID tag, the reader in the tag must have the same frequency. The RFID RC522 module reads only high-frequency tags reading at the 13.56 megahertz bandwidth. This RFID module comes with 8 pins, of which 7 are connected to the Arduino unit for this project. The RFID module runs at 3.3 volts. It needs to be grounded. Therefore, the module's 3.3 volt pin must be connected to the Arduinos in order for it to function. When an RFID tag or card comes in with close proximity of a reader, it is powered by electromagnetic induction from the RFID module and begins to communicate. A chip inside the tag can be read or written to using proper two-way radio transmitter receiver modules. Now for the Arduino. Arduino refers to an inexpensive open source electronics platform in the software used to program it. It usually contains a microcontroller and provides additional necessary power in data connections already attached. An Arduino board can be purchased pre-assembled, or because the hardware design is open source, it can be built by hand. Either way, users can adapt these Arduino boards to meet their needs, as well as update and sell their own versions. The primary mode of computer communication with the Arduino is via USB, but you can also attach capabilities such as Bluetooth, Ethernet, and Wi-Fi to facilitate communication. This solution is inexpensive, uses little power for this project, and is small enough to create an easily portable device. Here are the components I used for this particular prototype. For our hardware, we used open source branded Uno Arduino board. It's the revision 3, which is the modern revision of Arduino. I also used an RFID RC522 module. I used proper male to female jumpers, USB to DisplayPort cable to facilitate communication between the laptop and the Arduino, and of course a laptop with Windows 10. For the software component, all you need to use is the Arduino Integrated Development Environment. The Arduino Integrated Development Environment contains a text editor for writing code, a message area for debugging in errors, a text console, a toolbar with buttons for common functions, and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. The Arduino IDE is available across all major operating system platforms and uses the C++ programming language. When you start the Arduino IDE, you get an empty page where you can enter your code. A sketch is the name Arduino uses for a program. It's the unit of code that is uploaded to and run on an Arduino board. Libraries are also available for download through the Arduino IDE or off the internet. Libraries make programming the Arduino much easier since they contain the code needed to control certain modules and sensors available for the Arduino. They add functions that help the C++ code work with the Arduino's pinning and other architecture. No programming is needed, as the code to perform the RFID operations have been provided as a downloadable library within the Arduino integrated development environment. I simply searched for the library matching my MFRC522 module and module reader. Once installed, the library adds a sketch code needed for my device to function and presents it in a drop-down menu. I simply selected the code and chose Upload. The code will be compiled from C++ into machine-readable language and then sent to the Arduino microcontroller via the USB. When examining the sketch code in the IDE window, it provides instructions how to properly connect the pinning between the Arduino and the RFID reader. We must also connect the correct power and ground wires in order to provide power to the reader, which are both powered via the USB connection from the laptop. When connecting the 3.3 volt pins, be careful not to touch the 5-pole pins, as this could harm the RFID reader. You need to configure the integrated development environment to the correct Arduino type in the communication port before it will upload your code. You can add one sketch at a time. Here's a picture of the complete prototype build. Once the sketch code is uploaded to the Arduino, the user just needs to open the serial monitor that comes as a tool in the Arduino integrated development environment. The RFID reader sends the UID, which is a unique identification number associated with the tag or the card, to the serial monitor. Each smart card contains an integrated chip with a unique permanent identification number burned in during the manufacturing process. The results of each tag scan is listed in the serial monitor. The managers could also choose to implement a write sketch. With this write sketch, the managers have the option of replacing the tag unique identification numbers with employees' names if they do desire. So this solution prototype meets the requirements laid out by Tenco Incorporated and could easily be developed into a low-power, portable, and easy-to-use device. Thank you for watching this presentation.